how do I undo again? Control Z maybe? No. Do you know how to undo? Is that?
Yeah, what do you want to undo?
Well, I deleted a cell, and I can remake it, but I just wanted to undo. I think there's an undo. How do you? No, but it must be Control MZ, maybe Control MZ. Yes, but it's through M. Anyway, thank you. So, yeah, the split somehow I'm not able to do it with the shortcut, even if I looked it up and.
Never done it before.
But. Yeah, but it doesn't work when I do it. Like, for example, see, I'm here, and I go like Control, Shift, no, minus, but it doesn't do anything. So it's a bit of a mystery for me, but. Okay, so 2 exercises right now to use built-in functions, so that ship directly with Python. Functions like print, max, min, len, and then accessing elements of a character string. Oh yeah, actually, normally the coffee break is right now, so like after these exercises. So we're not too bad. And again, all the materials are up online, so you'll be able to read them in a linear way, like sequentially in order if you need to like find something that you don't remember, or if you've missed a part, or if it didn't seem to make any sense, you'll be able to read the one cell after another, even if you have to put up with my moving around, creating a new cell above, below. And so what do you expect this print call to do? Yeah, so it's called it's called calling a function, right? Maybe you're familiar with this language already. So it's see, yes? We can always double check. I'm gonna run it. Yeah. And now, what do you expect to get? 10. Oh. Here. How many? How much? Oh, I thought you were giving an answer. Yeah? 4. Yeah. And here, what do you think of this code of line, this line of code? It won't work. Do I? Because you're trying to take, so first of all, we're getting the length of this character string, so 4. But poor is a character string, so what's the max between an integer and a character string? It doesn't make any sense. And by the way, that's also one reason to, it's not the main reason perhaps, but to not use Python 2 anymore, but really use Python 3, because in Python 2, actually, you could compare a character string and an integer, which is a bit scary because it doesn't make any sense. So your code would run and would not spit any error, and you could just keep going. So I think that's one of the things that were a bit disturbing and unsafe. But I mean, the other reason is that Python 2 will be decommissioned in less than 2 years, in like a year and a half anyway. So and I know a lot of scientific code, I mean, there is some legacy code in Python 2 in some scientific labs. So yeah, let me know if you have this problem, and I will try to help you, even technically and maybe even politically. And now second exercise. So we've seen that indexing starts at 0. That length returns the number of characters in a string. And now figure out the expression to get the last character in a string called name. But name, name could be my name, your name, etc. So think in the abstract sense. Does someone have a suggestion? So, length. How do I write it here? Yeah. Because if I passed length name. Right, I would be out of bound since the index of y here is 0, so this one is the total length minus 1. Okay, I think we can take a 15-minute break and meet here at 15:20. What? Oh, coffee break? Yes, please, thank you. Yeah. I don't know if I have to turn it off. Mirko, should I turn off the mic? Oh, yeah, for the remote people, we're having a 15-minute coffee break. Maybe I should have been right here, I don't know.
Exactly. Yeah. So either half, maybe half to half.
Welcome back. I'm starting a new notebook, so at least for a little while, we're going linear and executing cells in order. Yeah, in your case, I don't know where you're at, whether you're, if your notebook is very messy, it's normal, take it as a sandbox, clean it up afterwards if you like, even as an exercise to let the knowledge sink in, or remove it and look up the reference materials. But for example, right now, maybe you also want to start with a fresh notebook, or at least maybe clean up all the variables maybe that were defined, etc. If you do a restart, a kernel restart, all this will be flushed from Python's memory. So right now, we're going to talk about libraries. Okay, I realize that libraries and packages are not exactly the same thing, but for the purpose of today's lesson, I'm going to use the terms a bit interchangeably, even with the term modules. In R, do people practice R in this room at all? Okay. Oh, good. I do too. So in R, the distinction is at least culturally more important in the sense that a package is really like the collection of functions and utilities that are made available through the import of that package, and the library is the path, the file path, really in the sense of the PWD that we did this morning for that package. In Python, I think it's less of an issue if we use the two terms interchangeably. So what's a library? So libraries are really the reasons why you would want to use some software like Python. So libraries are a collection of modules. So modules are py files, so Python programs, and inside of them you have a bunch of functions, sometimes also constants. So for example, I could make a package about, I don't know, gravity, and there would be functions that lets you compute, gravitational attraction, and there would be a constant that would be the universal gravity constant and things like that. So typically, usually you develop this set of functions into modules and all collected together form a library around a certain theme. So your research is in gravitation. Someone does gravitational stuff, right? Anyway. But really the code doesn't care. So there's nothing that enforces the fact that all these code units, so code units being functions or variables like constants defined and made available for you, they don't have to be related. It's just that we're humans and we work on topics that make sense. So usually a package or library has a certain theme, a certain topic. And I can tell you that the scientific Python ecosystem is very rich. So you'd be amazed. I was talking with some of you earlier about SymPy. So it's a Python package for symbolic calculus. So if you're interested in symbolic calculus, just check that out, and you'll see that a bunch of utilities, all the functions that you want, that you need, most likely will be there. And if they're not, maybe you can try and contribute to this package, because Python is free and open source software, so it's very convenient. You can study the code, and you can contribute code to those packages to enhance them and improve them. So far the functions that we used were built-in functions. So they were readily available like this in plain Python. Now, if we're talking about more specific, kind of domain-specific functions that are found in libraries, we will need to import these libraries to have access to what they contain. So for example, we want to do math. So for example, we want the number pi. Well, of course, it's an approximation of the number pi. We want to be able to compute the cosine or the square root. And right off the bat, I cannot just go like cosine of pi. That doesn't work. So I need to get that cosine function and this pi value from a dedicated package. And this will be, okay, sorry, I just did what I said I wouldn't do anymore. So linear, 1, 2. So import math. And now, in math, I'm going to use the dot notation to see what's available in math. And if I press tab after the dot, I see that there's an arc cosine function. Bodes pretty well. Oh, cosine here. So here, for example, the cosine of 0. Oops. It's a new laptop, so I'm a bit clumsy. Well, which is good, so that you show all the typos or the trying and probing. And it returns 1 as you would expect. Pi is also available like this. So if I start typing pi and tab to autocomplete, there we go. I run it. And I have pi up to a certain number of decimals. To know more about the math library, or the math module, so actually we can say it's part of the standard library of Python. So that means that I didn't have to install anything specific. So when you got set up for this course, you probably had to do something slightly specific, such as using Anaconda to get the pandas package, for example, because pandas is not part of the standard library, but math is. So I can just go like import math, and with my install of Python 3, it will be there. If I do import pandas, I will need to have installed it ahead of time. So help, so again, in real life, honestly, I would search it online, but let's do it by the book. You have some documentation about the math module. So here you have a list of all the functions that are available. The constants, so the data that's available here. The number e, infinity, not a number, pi, tau, I'm not sure what that is. It's what? 2 times pi, that's all? Oh, okay.
Tau.
Yeah, but in which fields do you?
Some mathematicians which are crazy prefer to use tau instead of pi.
See, always a problem of a factor of 2. Okay, thanks. Another way, so like now, yeah, just so you know, it's very common at least in scientific Python, to alias module names. So you're going to import math as M for short. And this means that later on, when you want to access pi, for example, you just need to type m.pi. So that can make for shorter lines of code that can be useful. And we'll see that for the popular scientific packages, there are standard aliases. So this is called the alias. And this is the full module name. Okay, so I'll give you an exercise now. Maybe, let me see. This will look better in Markdown. Oh no, that's weird. Okay, so 3 little exercises. First one here. Oh, and I'll be really linear. I will split this cell so that we can have the code answer below. So can someone tell me which function they would use to calculate the square root of a number, but without using the one that's called SQRT? Hmm? Mm-hmm. Yeah, so like you're saying, for example, 9. So that's the notation for elevated 2. And but we want to use, so that works, but we want to use a function from the math module. It's a bit artificial, right? I'm not saying that in your real research you have to really worry about it, but that exposes you to what's available, and actually we get to see a bit of the history of programming behind that, because the math module is comes from C. So if you go like tab, you can explore. So that maybe that you can find the inspiration there. What would you do?
Power.
Yeah. So power, and now what do I type?
9 and 1 hour.
Yeah, or for example 0.5. So you might think that having math.square root, which is also available, as you can see, you might think that this is useless or redundant, since there are other ways to do it, as you can see. Yeah, sure, but you know, programming is not just for the machine. Actually, I would argue that it's primarily for the humans. So readability matters, and since square root, at least in certain fields, is a very common operation that you want to perform, you know, as you read your code, seeing the square root function, you know, you can parse it with your human brain probably much faster than this thing where you have to see like, oh, okay, it's the power of 1/2, and or this. So it's a matter of readability. Oops. Otherwise, this function contains 2 arguments, which is already introducing more cognitive load. Now, exercise 2. Okay, actually this I should put in a code cell. Oops. Oh, no, I didn't want to do this. Excuse me. I'm abusing the keyboard shortcuts. And I'm going to leave this as code. Oops, sorry. Let's ignore this. Okay, we're at exercise 2. According to you, what module from the standard library would I want to use to select randomly one of the bases in that sequence of base, one of the bases, yeah, in that sequence? What do you think about when you want to sample, when you want to get an element out of many? But not the first, not the last, just one of them. What comes to mind? Yes, very good, random numbers. So, surprisingly, there's a module in the standard library called random. And you can get, oops, sorry. You can find out more about it by running help. Sample, random ranges, bunch of things. Or again, like I often do, I go like random dot tab, and I kind of see what could be helpful. So for example, randint sounds like random integer, right? So how do I use this function? Okay, I need to pass an argument. Oh, two arguments. Let's look at the docs. Control. What's the? No. What's the shortcut again? Thank you. Oh, okay. So return a random integer in range AB, including. Okay. Okay. So that sounds like it could be useful, right? So something between 0 and 10, for example. There, you get to pick one. If I rerun it, so confusion of I rerun it, I get another random integer. So how could that be helpful? Maybe, I don't know. What do you think? With this character string that I have, can someone suggest some code? Or type it in the Etherpad if you're really shy.
No one is going to know who you are.
Yes, I will copy paste it from here.
Maybe basis.
Yes.
Square brackets.
Yeah, to select something, absolutely.
And then random dot randint from 0 to len basis. -1.
Okay, nice. Thanks. Was there another question? Are there alternatives? Actually, yes, many. I think maybe rand ranges could also come in handy. So choose a random item from range. This fixes the problem with the... okay. This is usually not what you want. So with rand range, it would be slightly more elegant and readable, right? In the sense that you could use random rand range from 0 length bases. And you wouldn't need to remember that the length of the character string is off range with respect to the indexing of each element. Okay, third exercise. So how can I unrun this actually? Oh, I know, maybe if I turn it back into Markdown and then code. Yeah, there we go. So yeah, now the question, so of course to be able to use functions from a module, you need to import that module first. So, and then you have access to its functions or its data. Think about constants like E or tau that we just discovered. So now please match those print commands with the proper imports that were required. And maybe this last import will ring a bell with respect to this morning. Can someone share their intuition about what from math import star would do? Right. It would import everything from the math module. Is that good? Is that bad? Do you have an opinion?
If I'm using just math, it's okay.
Yeah.
If I'm using a lot of library, maybe it's not the best idea.
Exactly. So maybe you like the possibility of just typing pi instead of math.pi instead of m.pi. But if you have imported other libraries that have functions with the same names and you don't even know in advance, that would create conflicts or confusion. And in general, it's not recommended. So, for example, if you really want to be able to use the number pi as pi directly without having this like prefix dot, what you can do is what's shown here in the first line. You import explicitly pi, and in this case the sine function from math. That's like much better. I would not recommend this. Okay. Let's move on to tabular data. Yeah. So I would assume that most of you work with data that's stored in tables, right? Where you have rows and columns. Right. It's not the only structure for data, but when we talk about data analysis, usually that's what we start with, and that's very common in many fields. So we're going to read some of the CSV files that are found in the data folder. So far, you know, in this directory, we were importing the Python files from the code subdirectory. Now we're going to, here, if you notice that you can kind of browse the tree here from the Jupyter interface. In data, you have a bunch of CSV files. Are you familiar with that format? Comma-separated values. Yeah. So it's great because it's just like the Python files, actually. It's also a plain text format. So the machine can read it and the human can read it as well. So, and there's a very convenient package or library in Python called pandas. It's very inspired by R. I mean, maybe I don't need to say this, but I say it because I was going to say I come from R. It's not quite true because I started programming in Python before, but then in industry I became overwhelmingly an R person. And then when pandas developed, you may be aware that it's fairly recent. Even maybe 5 years ago, you know, the landscape was very different. Then I was like, oh, okay, now this is available in pandas as well. So like the development of pandas is very inspired and stimulated, even if not only, but by especially what's available in R right now around the tidyverse. So I'm mentioning this word because I'll say it again. I'll talk about tidy data, even if it's not the focus of this afternoon. So should I start a new notebook? Just in case? Yeah. Let's be clean. So I want to import pandas to have all these utilities and statistical analysis functions that I can apply on tabular data. My tabular data being stored in my CSV files. And so I can just like import pandas like we did import math, except that for pandas you will need to have installed it ahead of time. It's very common to alias it this way, import pandas as PD, so we'll do it. And there again, I'm going to use tab to see what's available, and I want to read CSVs, and oh, there's a function called the read CSV. How nice. And there, the argument is going to be the file path. So in data, I'm going to read, actually, I can press tab to see, is it not available? Why is it not, there's no way I'm typing this file name myself. I want it auto-completed. Where am I? Oops.
I think you are inside the data folder. So.
Let me check this. Oh, you're right. How? Oh, yeah, because yeah. Okay. So I don't want to do this. Let's move back up and create a new notebook and call it part 3. Part 4 by now. So I'll just re-import pandas as PD. PD read CSV data, and I'm going to load Oceania. So here I have a nice table made up of 2 rows. Well, because there are only 2 countries in Oceania. Right. That's a simplification.
Some islands, but
oops. In this simplified data set, there are only 2 rows.
Only 2 that matter. And one of them could be
yeah, so the concept of tidy data, yeah, I'll just introduce it. It's not officially part of the lesson, but I think it's pretty useful in the world of data analysis to be aware of it. The idea is that every row, every line represents a record, an observation, and every column represents a variable that's being observed. So that's what you would expect anyway. But sometimes you want to do manipulation between long-form data. Yeah, so for example, if the triplet, what could it be that? Yeah, for example, if you have more of a heat map visualization of things where, you have, I don't know, days of the weeks. So Monday through Sunday, and here hours of the day, and then you have, I don't know, the mean temperature, in Trento, for example. So you imagine this matrix, and then you could visualize it with like colors. So that's like a matrix form of your data, but you can have the long form of this where you would have, day of the week as a column, hour of the day as a column, and value of the temperature. And that, I think that's called triplet, or I mean, whatever the argument, but you get the idea that it's the same data, but in different representations. And the thing is, it's important to know which representation you're in, because then you'll be able to call certain functions, like for example, in the first case, the heat map is, you know, straightforward. But in other cases, you want the other representation to be able to plot certain things, plotting or carrying out statistical analysis. Pandas, honestly, is very well equipped to handle all this. Now, actually, let's store this tabular data in a variable. So we know how to do this. We go like data equals PD, read CSV, data gapminder. And I'm going to further specify that I want the index. Yeah, I want like the column country to serve as the index. So, to be honest, the use right now is not necessarily super striking. I think it's a lot more striking when you have time series type of data. So for example, the first column will be different timestamps. So, you know, it's all fine, but maybe you want to really specify that it's not just that first point, second point. So like the 0, 1 here, or the kind of default, what you expect, like numerical indices that are just integers incrementing. But maybe you really want, you know, the x, for example, of your graphs to be that timestamp. So when you set the index to be date or date time, it's really useful for later operations. Here we show a very simple example where we index by country. What you can do with, okay, so let's inquire about the type of data. So the data variable is a pandas data frame. So data frame comes from R, hence the heritage, if you like. And I'm going to use the dot notation and tab to see what's available there. And I say, oh, T, so I can transpose my data. So I see that my columns can become indices, and my rows can become my values of interest, like this. Actually, I cannot resist but show you immediately. Oh, no. So yeah, I wanted to plot this because, of course, to teach the basics, we go like, oh, how do you select one element? How do you select a subset, etc. But in real life, you just want to see what it looks like, you know? So let's skip a little part and maybe come back to it afterwards. I think we're kind of on time, so I'm not too worried. The most popular plotting package, so scientific package for graphing in Python, is called matplotlib. Maybe you've heard about it. So the way you import it is matplotlib, and we use a module specifically called pyplot, so a module from the matplotlib library, patplot, and it's very long, so we definitely want to alias this, and the standard is to call it plt. And we use another magic command. Remember the load command here, it's going to be matplotlib itself, and inline to have the graphs directly inside the notebook. We want the graphs to display inline as opposed to pop in another window all over the screen. So I just wanted to make plotting available because Pandas uses it implicitly, so it's available even if you don't see it explicitly in the syntax. So if I call this, yay! So really, I mean, as much as we can do a bunch of other things, like for example, maybe you want some information about this data frame. So this data frame, so tabular data, has the following columns, so variables, assuming that the data is already in so-called tidy format. maybe there's a third criterion for tidy data that I didn't mention, but it was that you know that each cell contains a value. So if there's a missing value, there's a way to signify it, either null or a conventional value. For example, negative values for quantities that are normally positive. So this is more on the side of data management, data collection, data curation, but of course it's important. But you know, honestly, between taking a look at this and trying to see what my data is about and taking a look at this, I think, you know, it's pretty clear that we just want to take a look and see something. So I didn't want to push like the plotting part only towards the very end, because in real life, I'm sorry, but that's the first thing you do. And then maybe you want to look at the summary statistics. So for example, you have the describe method for this. So data.describe. If you run this, you get a statistics summary for each variable. So each variable, each column, you have the count. So here you only have 2 values. So the statistics computed on 2 values, that's not necessarily super exciting. But here you can get like a sense of maybe, for example, the evolution of the mean. So you see that the GDP overall seems to be increasing, and that kind of makes sense. If you were seeing a mean value like this decreasing, you'd be like, okay, wait, I need to go back, you know, one step prior. Either it's like my actual data set that has a problem, or I massaged it in a way that, you know, I reversed the time or something. Yeah, so I think I pronounced the word method, so don't worry too much about it. It's a function that's available for certain types of objects. So because data is a data frame, the describe method is available. So it's the describe method is a function defined for data frames. And here the fact that we were able to get this time series like plot directly just by calling the plot method after transposing data is because we had, so this is also a form of tidy data. If we consider that we want GDP values for Australia in one column, GDP values for New Zealand in another column, and that in this case our index is these years. Okay, so now we're going to see how we can select elements. So remember that we saw how we can select elements of a character string. So with those square brackets, 0 being the first index, the last index being length of the character string -1, and the slices being denoted by the semicolon. So here it's going to be a little reminiscent, but a little different, because data frames, the position, so a row has a position as well as a label, just like also a column has a position, the first column, the second column, but more importantly, it has a label. So for example, when I look at this transport version of my data, you know, it's more relevant to say, you know, I'm interested in column Australia, so the label. Whereas saying I'm interested in the first column, you know, it's not like you remember what the first column is and which order. Yeah, so for example, so when we talk about positional, so like the number indices, we're going to use the iloc method. So data .t, for example. So iloc 0, 0. Okay, but so we have to scroll back up to figure out what that was. So here, okay, so that's like for Australia, the GDP in 1952. So it's a lot friendlier to access elements not by position but by label, and for this you use lock instead of ilock. So here, actually, the row, since it's not called just 1952 but GDP, I didn't memorize it, so I'll use 0 again. But here I want to use Australia. Oh no, I cannot. Oh yeah. So I guess it's ilock still. I mixed it. Maybe not. Wait. Value error. Location based. Wait. Type error.
You can mix.
Yeah, maybe, but normally, okay, yeah, so let's do it gradually. But, and I think it auto-completes anyway, so GDP. GDP per cap. 1952. Okay, but I think you can mix the two, because, okay, let's go back to the non-transposed form. If I do lock, oops, Australia, and then the first row, the first column, sorry. Oh no. Okay, it's kind of consistent in a way, but I really thought that you could.
You can index also without lock for the Australia, and then use lock for the column.
Yeah, so so if you don't use lock, by default you can select columns. So you can go like data, for example. And you get a series. So like the type of this is actually a series. So each column in a data frame is a series. Hence like the ease of plotting. Because again, like here I can go like data T, Australia, plot. And by default it plots this way, but I could plot as a bar chart equals bar. Okay, that here the colors are not meaningful, but you know they're different colors because there's a different index each time. What I wanted to show was that if you want to keep a data frame and not get a series. So a data frame is a two-dimensional object, it's a table, whereas a series is one-dimensional. But if you wanted to keep like a two-dimensional object, so data frame, you would use the double bracket notation like this. Oops. And here you see that the values contained are the same as here. But you still have the structure of, okay, I have like my index here and my values here under Australia. But to go back to your suggestion, so let's take the series, the values for Australia. Yeah, and now, yeah, but that's like, it's bad to do this. Because yeah, there's actually a nice little explanation in the Pandas docs online. I'll put the link to it. But it's better to like decide, which place of the table you want to reach, and then retrieve that value, rather than take a copy of a part of it and then take another part. And in some cases, it can create confusion. I can also point you to other materials where I've touched on this. But yeah, so what did I want to show? oh yeah, the slicing. So let's maybe import the data for Europe, because since we have only 2 countries here, it's not like we can take like an extensive range. So Europe, PD, read CSV, data, GDP. So here it's much longer. So maybe that's like a bit overwhelming in your screen. Maybe you just want to like take a look at the head. So this will display only the 5 first lines. It's not like 10 in shell, it's 5. But if I wanted 10, actually, I could like override the default argument like this and get the 10 first European countries by alphabetical order. I could also get the last one with tail. Let me get only the last 2 ones. Yeah, and actually let me give you an exercise because it's exactly on this, and then we'll come back to the subsetting and slicing. Can you read well? I mean, you should be able to load this this Python program on your end as well anyway. Green stick is up when you're done. I'll come and see your. So where's your code?
Sorry.
Do the exercises, and when you're done, yeah. so confused. I thought this. Yeah, and then. Hmm? Yeah, yeah. Do everything. Yeah. It's not hard. No. Because you're told what to use. Yeah.
So what would be the data frame that I want to write on a file?
Hmm?
Which data frame would I want to write as a file?
You can rewrite the same one. So either the Europe or Oceania one. I don't know. Did I want to do PD? Version is like this. Yeah, maybe I'm not up to date. Because I'm pretty sure that I used to do a label for, let's say, the row and position for the column, and or vice versa. But in a way, I think it's safer this way, that they don't let you mix up. But I'm pretty sure I've done it in the past when it was like version 20 and before. But yeah. Yeah, actually, I'll write a note because I think that the lessons are. Okay, some people have completed the 3 exercises, but some others not quite. Oh, yeah, a second. So. Was everyone good with the first exercise? If not, call a helper. Was everyone good with the second exercise? Nope. I heard. Head and tail we just did together, actually. And the third exercise, it's like once you've transformed the data, so like we're not doing super advanced stuff right now. So I'll just mention it so that you know it exists. Okay, are we back together? So usually what people want to do, are people familiar with databases and SQL? Do you use that in your work? It's okay. It's not too hard. If you need it one day, you will learn it. And if you're a physicist, you will not struggle. So usually the strategy you want to apply is split, apply, combine. So for example, you will want to split your data along some values. Actually, in a second, I'll show you how to, select all the GDPs that are, above a certain value, for example. So you want to split. Then you want to apply a transformation. So for example, you want to compute a certain delta or mean or something. You want to apply a statistical or mathematical operation on it, and then you want to recombine it in order to visualize it. So this would be a lesson in itself, the split, apply, combine, but again, I'll point you to good references for it. So at this point, your table really doesn't look like what it looked when you loaded the raw data set. So maybe you're happy with this new table, which is all rearranged according to the filters and the transformations that you've done to it, and maybe you want to save it. Maybe it's an intermediate output, maybe it's the final output, maybe it's the input of a visualization. You want to save it in another CSV file. So that's what the third exercise is about, even if in this case we haven't dramatically transformed the data. Actually, yeah, we could have just added a quantity somewhere to pretend that we did something. But yeah, the idea is just that you would save your normally transformed data into a new CSV file. So it's been processed, assuming. So now you want to save it into processed.csv. And now if I go, if I look at the tree, my structure here, now I have a new CSV file. And well, in this case, it's the same because I haven't done any processing. But of course, you want to be able not just to read data, but also to write it. Yeah, so now something about slicing. So it's very, very convenient. So also the reason why we teach, even though it's a very brief overview and very limited, we don't cover that much, but we do pandas and not NumPy, because in NumPy you're able to manipulate numbers, matrices, do all sorts of computations, but in pandas you can do that on the numbers, but also on things that may not be numbers, like Italy and Poland. They're words. So you want to take the range, not the range that's from like the third country in the list to the 13th, because you don't really remember what that is. You want to go from Italy to Poland. So that's what it's doing here. And column-wise, you want to go from 1952 through 1962. Can someone share their first impression as in terms of my slicing, thinking about what we did with character strings, where you had to take length -1, etc. What are you noticing here? Are you noticing a difference?
In this case, we are not excluding the last...
Exactly. We're including it. So that's something to keep in mind, because maybe you go back and forth in your slicing, and it's like the same syntax with the semicolon, but here the last, the end of the range is included. Also something super powerful that I have to show you is that even if you write, for example, in this year, a year that doesn't exist, so let's say here we jump from 62 to 67, let me write 65. It actually works. So, pandas can handle this. So if ever you had, holes in your data, and later on you were to give the 1963 data points, whatever, they become available at some point, your code would still run and you would not need to update it. So that's also very, very useful for time series. The ability to slice like this, to slice without relying on positional indexing. Yeah, so back to plotting. So we've seen that Matplotlib, or maybe, I don't know if we have time to do exercises. I'll just say a few more things about plotting so that I leave you with at least something that's self-consistent. And even if we don't finish the exercises, you can email me, you can look at the solution online. You're never going to be alone in the SciPy world, and that's the beauty of it. I mean, you can be alone if you want to, it's up to you. So, we have the PyPlot module from Matplotlib that's loaded as PLT. If I have a range of time, which I'm going to define very simply here as a list. And values, what would they be? Position, let's say. To be honest, Matplotlib syntax is impossible to memorize, you know, but it's okay, just research it. Whereas from pandas, you can already plot a lot without having to memorize crazy arguments, keywords, and stuff like that. T hours. That would be the Y label. So yeah, so the plot function, you know, it's quite straightforward, even though, you know, it's not like you should memorize how to add the Y label and the X label, you know, look it up when you need it. Pandas data frames use Matplotlib implicitly, like we've seen before. So actually, let's plot the GDP per capita in Australia over the years. So we had data. We have the data here. We would like to index these values by the years directly. So we're going to have to do some transformation. We want to get the years directly. So that's going to be data dot maybe I'll show it gradually so it makes more sense. So again, I don't memorize much, but you know, I use tab, and then I'm like, oh, what are the columns? Oh yeah, columns, sure. So they live in an index object because that's where the power of data frames comes in. We want to parse and strip those strings to keep only the year. So if I say data.columns string, I think the syntax is strip, and the GDP per cap underscore, I want to remove. Okay, nice. So I'm left with just the numbers. And this I want to convert into an integer. I'm not sure if taking int of this would work. No, so yeah, right. So I have to do like as type, so a method that's available for an object of type index as type int. Yeah, actually, here it says object. You can think of it as string, for the purposes of this lesson. See that 1952, etc., are between quotes, so they're strings, and we want to turn these strings into integers. So for this, you use the as type method. So these are going to be our years. So years equals. And then, yeah, I think, oh yeah, so data. Maybe I'm going to overwrite the columns with that. Yeah, so far the columns of the data from data are these, and I'm going to say from now on, there we go. So now data looks like this. And now I think if I just take the transpose so that my years are the index, so let's say the x-axis in the time series type of object, I can plot this directly. Yes, and I have the years there. And it's since especially the years don't follow each other. I mean, they seem to be evenly spaced by 5 years, but you know, we wouldn't want to just like plot the sequence of GDP values. We want them to be associated with the right year. Yeah, and then maybe what we want to do, so maybe we would add some styling. For example, a popular style is do I have the syntax for it? Yeah, PLT. A popular style would be the ggplot style from R. So style, use ggplot. And there's this gray background with the grid in white. Maybe I want to add a Y label that says GDP per capita. And finally, maybe I want to save that figure to send it to my collaborator or to for it to be part of my paper. So I'm going to use, I don't know if this will work actually, so let me try. I'll just copy that. It's the savefig function. In, so I'm going to save it here. GDP .png. So let's check this file and see if it contains my. I'm not exactly sure. I will explain you why in just a bit. Okay. GDP. Oh, no, okay, it works. Sometimes, so it lives here. I could have saved an EPS if I wanted to, etc. Sometimes you have to make sure that you get the current figure as an object to save it in a PNG file, because when you use matplotlib through pandas, hence implicitly, sometimes what PLT has in mind is actually a new empty figure. So just to be aware of it. But anyway, that's something you do with trial and error. I don't know if we have time for some plotting exercises. Yeah, it's not too hard, so I think you can do it quickly. And in the Etherpad, I'll point you to more resources so that you can dig deeper. Yeah, the lesson materials also contains a comparison, if you like, so like the New Zealand GDP per capita over time versus the Australian one, because, you know, as you can see from here, there's a crossover at some point, and that's cool. But actually, I find that you don't really get the point if the aspect ratio is not 1, because you know, you want a square to visually compare with the first bisector. So one way I found to do it was to impose a fixed size, that square. I'm sure there are other workarounds. But so you can kind of like, and also, you know, we would draw it if we wanted to be really specific about it, but here we can see that New Zealand was above and then below Australia, which will please our friend. And also, you can see that the syntax is not like super strict, and well, basically there's more than one way to do it, because to have specific kinds of plots, so bar charts, scatter plots, etc., you can either pass, you know, kind equals bar, kind equals scatter in the plot function, or you can do this kind of chaining of methods like this. Yeah, if you, it's worth putting some thought into it. In some cases, it doesn't matter. In some others, you may notice it in your workflows when you build a sort of pipeline that goes from like some sort of cleanup or standardization of your data, and maybe goes through processing steps and ends with a visualization. Sometimes some issues appear, and then you make a choice that you stick with for the rest of your project. Are you good? So what do I write here? So I've loaded data. Europe is, oh yeah, right, thank you. So I'm interested in the min. I don't know. I'm trying a bit blindly. Just. Fun. Oh yeah. Thanks. And what does that do? Oh yeah. Sorry, that has nothing to do. Non c'entra. Yeah, min is a function. And I'll just delete this. And the second exercise, How would you comment that? So yeah, you're discovering that the plot function can take several arguments. So it's very useful for customization of your visualization. You can specify the kind. So it's a scatter plot with x-axis, y-axis. And what is this? Did you run this and did you get the... Yeah. So yeah, the quantity that we're representing is the population in millions. But visually, how is it represented? It's called S, which is not super explicit, I agree. It's the size of the dot. And then you could use yet another dimension, which would be maybe the color. You could have a color gradient if you wanted to represent yet another dimension. Then there's a point also where maybe the picture becomes very pretty, but it's also very confusing. So there's a nice, a happy medium to find. And then you can make those plots interactive and web-based using packages like Bokeh or Plotly, and the possibilities are infinite. And Dask, not the one for profiling, but the one for big data visualization. There's also YT for high-dimensional scientific data sets. So yeah, data visualization is yet another Pandora box. Yes?
When we do the operation minimum or maximum,
So yes, here.
it scans over the rows, so over the columns.
That's a very good question. Yeah. So as you can see, by default, it scans over all the rows. So the rows, so like a matrix, it's row by column. So it's like first dimension, index 0, second dimension, so index 1. It's called an axis in pandas. So axis 0 is across all rows. Axis 1 is across all columns. So here we didn't specify anything, and you can see that actually it is axis 0.
Because if it's not non-pointing indexes, we should do by columns.
Maybe it's the way you say it, but it's like across rows, basically.
But what does it do? The sum of the elements, or
The minimum. So it goes across all the rows, and it takes the minimum of that.
in general?
Yeah, across all the rows.
Different rows, even.
Yeah, because it's like an operation over all the rows. So for the first column, you take all the rows, and you get the minimum. Second, etc. If you wanted to do it the other way around, so if you wanted to take the minimum GDP over history for each country, instead you would use axis 1 here instead of 0. But the default is axis 0, which means across all the rows.
So let's
Yeah.
say that one is not a plot related to one single country. Let's say it doesn't select.
No, it's over all the countries precisely, yeah. But yeah, if you study what I mentioned, split, apply, combine, that's exactly the kind of questions that you want to pay attention to. Because there's a moment where maybe you do some kind of filtering, you separate things, and then you need to decide over what do I do my grouping operations. So you have operations that reduce your data sets. So for example, if you take the mean, or the max, or the min, or the standard deviation, that you start with like n points and you end with 1. So you've reduced the size of your data set. You've done like a grouping operation. Whereas if your operation is to, let's say, take the square root, you had elements and then you have n elements, And then you even have, if you do interpolation, things like that, you can even augment the size of your process data sets. Yeah, that's also the differences you can get on time series. For example, you can sample or do sampling or rolling, and in either case, the idea is to smooth your time series, but one of them reduces the size of your, so sampling reduces the size of your data sets, whereas rolling will not reduce the size of your data set. Welcome. So I think we'll end it here for the Python lesson. As usual, we'll ask you for a short piece of feedback, one thing that you learned and you liked, and one thing that you didn't like so much. And Lachlan has something to share about the make install for tomorrow.
So if you tried to install Make on a Windows computer, it probably didn't work. I don't know. It never works on my computer, but I now have a way to make it work. So if it didn't work for you, stick around for like 5 minutes. I'll tell you what the magic is. And then we'll try and get it so it works for everyone before we start tomorrow. Otherwise, I think we're free to go and do whatever it is we do after 5 p.m. Might be going back to work, it might be going home. Okay, thanks.
Thank you.
So Gianfranco's taking you back to see you, okay? Because he's heading there.
Okay, sounds perfect.
Okay. Fine.
He's around somewhere?
But if, yeah, I think so.
Yeah.
Goodbye,
Problems for tomorrow.
remote people.